Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on October 10, 2025, about 4 days ago. The big hook is that this paper introduces a reinforcement learning method that uses token perception and reports a 19.2% average accuracy boost at 7 billion scale and a 7.6% gain at 32 billion. The paper is titled Spotlight on Token Perception for Multimodal Reinforcement Learning, and the implications for model training are quite significant. In short, the method measures which tokens truly depend on the image, reweights trajectory credit accordingly, and updates only the perceptually pivotal tokens, yielding faster convergence and more stable training across 8 benchmarks. Also, the authors shared the official VPPO implementation on GitHub. You'll find installable Python code, a Vero core library, example training scripts for 7B and 32B models, evaluation scripts integrated with PapoEval, dataset configs, and reproducible setups via requirements and Docker files. There's a simple Conda setup and bash launchers to start training. On Hugging Face, you'll find VPPO model cards and examples for multimodal reasoning with 7 billion and 32 billion weights, BF16 safe tensors, quantized options, and Transformers Vision Chat inference snippets. Alright, Figure 1 illustrates how the method turns visual grounding into a focused learning signal. Token visual dependency means how much a generated token changes when the image is perturbed, so higher scores mark visually grounded steps. The left panels feed original and masked images with text into the model. The center module computes token dependency. The top right box shows trajectory advantage shaping, and the bottom right box shows token gradient filtering, which flow into the policy update. So Figure 2 shows how the method converts visual grounding into a targeted learning signal. The left panels run the policy on the original image and a masked image, which lets the system compare output distributions. The bottom module computes token visual dependency by measuring how different those distributions are. The top right block then shapes the trajectory advantage and masks pivotal tokens, so the policy update focuses on visually grounded steps. So Table 1 shows that the Visually-Perceptive Policy Optimization approach leads the field across 8 multimodal benchmarks. Average at 8 accuracy means the system samples 8 answers and scores the best match, which reduces randomness. The 7 billion model reaches about 58 on average, topping prior pure reinforcement learning baselines. The 32 billion model comes in around 65, which also leads comparable systems. Gains appear consistent across math, geometry, logic, and multidiscipline tasks. So Figure 7 shows how token perception pinpoints the core reasoning chain. The heat map highlights the top 40% most visually dependent tokens, which means the model's predictions change most when the image is perturbed. The left panel gives a geometry prompt, and the colored tokens on the right cluster around key concepts like circumference and specific angles. This focus explains why gradient filtering targets words such as since, therefore, and the think token. Wrapping up, 2 takeaways stand out. Token perception is sparse, so only a small slice of tokens truly depend on the image. And using that signal to shape trajectory credit and filter gradients, VPPO delivers sizable accuracy gains with faster, steadier training. The broader implication is clear. Modality-aware credit assignment should be standard in multimodal reinforcement learning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.